today on this wonderful journey we call computer science, okay, we are going to be learning about recursion, okay? All right, yay. Now, after recursion, there really isn't too much left that we have in terms of new curriculum. We're going to have to do searches. We're going to have to do sorts, okay? Sorts can be a little bit confusing, so I don't mind spending like a week or so on it, okay? But that's what we're going to focus on, okay? Searches and sorts, all right? Now, let's get started. Okay, also, before anything else, just asking you guys, is anybody going to need office hours on Friday? Please don't. It will make me want to eat my own soul. Okay, thank you. All right, good. Now, I just found out also that next year, for the first time, we will be offering Comp Sci Principles and Comp Sci A simultaneously. Joy. All right, let's get started, okay? Now, okay, all right, here we go. Let's have some fun in the sun. Optimize video clip. Nope, and no. I would also like to share with you that during this lesson, we will be having a visit by a little place I like to call Ono Hawaiian Barbecue. So, because I've been teaching nonstop and had to sub for somebody today, so I have not eaten lunch, okay? If you all have a problem with that, kiss my tushy. All right. I don't know if people still say tushy, but we'll just go with it. All right. Now, let's talk about recursion, okay? Now, okay? Repetition, recycle, okay? Redoing, okay? It's basically, imagine a loop without a loop. You're using a method in itself to be the loop, okay? So keep that in mind as we're going through this, all right? Okay, so the art of recursion. Note, this is not really art. No, nobody? All right, whatever. Guys, freaking A, it's the second to last day of class of the day, all right? Have some energy. Okay, what is it to recurse? Damn it. Damn it. I just cursed again. Thank you. That is recursion. Just kidding. Yes, I was lame enough to actually practice that and put it in a PowerPoint. You're welcome. All right. Okay, so, all right. Classic problem. Okay, looking at this from simple algebra 1 problem, factorial. Okay, n factorial. All right. Now let's say that I was to say 6 factorial. If I say 6 factorial, algebraically, that breaks down. Oh, geez. Okay, hold on. I'm coming out right now. Okay, so so 6 coming right here. Okay, our visitor is here. Give me 1 second. So 6 factorial, another way to say 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, correct? Now, what's another way that I could say 6 factorial? Couldn't I do 6 times 5 factorial? Wouldn't I get the same answer? Couldn't I, in writing 6 times 5 factorial, couldn't I do 6 times 5 times 4 factorial? Et cetera, okay? So that's, in terms of that, let's take a look at this example here, okay? Let me go back here. So let's take a look. 6 factorial, okay? Now on the left side, especially, okay, this class, I would have no problem if I asked all of you, without a doubt, nobody in this class section, if I said, write out a for loop that does 6 factorial. Without a doubt, I have confidence, every single one of you would go answer or num or answer equals 1 and j equals 1 or 0. Okay, probably not 0, but j is less than or equal to 6j plus plus. Answer equals answer times j, system print line the answer. Without a doubt, I have no doubts that all of you could do that or on a for loop. How many of you don't think you could? Perfect. Okay, now is the time, guys, to start exuding that confidence. Okay, if this stuff is starting to get boring to you because it's easy, then I've done my job. Okay, now method recursion. Let's take a look at the right-hand side though. Public int factorial int n. If n equals 1, return 1. Else, return n times factorial n minus 1. What do we notice about this problem?
It uses the method inside the method.
Who said that?
Vasily.
Vasily's right. We use factorial inside the method. Or the technical term that we say is the method is calling upon itself. Let's break how this works, okay? Public int factorial int n, okay? Int n equals 1, okay? The base case. So n equals 1, return 1 is the base case. Or some people refer to it as the terminating statement. In a recursive program or a recursive function, in this case, the return statement, so basically the best way to say it is like, you won't it's the statement where it stops and you don't call upon the method anymore. Did I call upon factorial in this if statement? No. Okay, I just did return 1. Else, return n times factorial n minus 1. Okay, so technically what is happening is it's returning n times factorial. It's returning n times. Okay, the multiplication symbol that you see there is what we call the process. By the process, we mean it is doing basically what is it doing with these numbers. Okay, so when we break it down, okay, let's look at this factorial problem. Public int boohis int n. If n equals 1, return 25. Else, return n plus. What is the terminating statement or the base case in this method?
The if.
No.
Return 25.
The whole thing. What is it?
If n equals to 1, return 25.
Okay, perfect. Okay, now the next thing is, what is the process?
Plus.
Addition. So when I say what is the process, what are we doing with these numbers? Okay, so first number we put in, let's say we did boohis 5. Okay, 5 goes in. Is 5 equal to 1? No. Else, return n plus. So it's important to understand the return wants to spit back information. Okay, it wants to spit it back. It really does. But what happens is it returns n5 and then it has this method. It has no choice. It has to run this method again. So what happens is 5 and plus gets stored. Okay, so 5 and plus basically down here gets stored. Then we run it with 1 or with 4 because we run it with n minus 1. 4 is equal to 1? No. 4 plus gets stored. 3 plus, 2 plus. Okay, and then finally we get to 1. But it just says return 25. The process says we're adding 25. So if I look at this equation in reverse, 5 plus got stored first, 4 plus, 3 plus, 2 plus, and then finally I add 25 to the equation. 25 plus 2 is 27, plus 23 is 30, plus 4 is 34, plus 5 is 39. Okay. It uses a process called LIFO that we will focus on in just a second. Okay. But for right now, take a minute, take a look at this equation. I want you guys to go at this equation for 1 minute. Oh, Hawaiian barbecue. You're never mean to me. Oh, Hawaiian barbecue. I had you on Lunar New Year. Go, hey, fat choy to me. Then I went to Little Saigon. This Vietnamese woman yelled at me. Why you talk to me like that? And I was like, stop yelling at me. All right. Kennedy, what's the terminating statement?
If n is less than or equal to 0, return 30.
Bingo. Benny, what is the process? Hold on 1 second.
Addition.
Okay, good. All right, so how many times is this going to run? Show me on your hand. One? Who said one? Vasily?
Well, doesn't it only run it once and then it just goes through again inside?
Okay. No, the method gets called multiple times. That's what recursion is. Okay, now, here we go. Let's go through it. Pardon my drawing. I'm going to draw as best as I can. 7. Okay, so we have 7. Okay, 7 goes in. Is 7 less than or equal to 30? So first of all, it runs 5 times. Okay, so the process is end. So what gets stored? 7 plus. Then minus 2, 5 plus. Okay, then what gets stored? 3 plus. Then what gets stored? 1 plus. Now the key thing is this. Now n, when we call it again, it's -1. Did I ask to return n? No. The only thing that matters to n is its relationship to that conditional statement. Okay. So now I return 30. Okay. What does that mean? All I do is I add a 30 to the end of it. And I work my way up. 30 plus 1 is 31. 31 plus 3 is 34. 34 plus 5 is 39. 35 plus 7 is, or 39 plus 7 is 46. Okay. That is how it is. Okay. 46. Okay. Now I wrote it this way, but the actual way that you should be writing it is 30 plus 1 plus 3 plus 5 and plus 7. It is a process that we call LIFO. Last in, first out. What was the first number? So imagine we're storing everything in a virtual dump truck per se, okay? What is the first thing that got put in?
7.
Plus 7, okay? Then plus 5, then plus 3, then plus 1. Now I return, and then it returned 30. So now I've got to empty this. So I take out 30, then I take out the plus 1, then I take out the plus 3, then I take out the plus 5, then I take out the plus 7. So if we were t-charting it, you're working your way down, and then you're working your way back up. Basically building an equation or an algorithm of sorts. Okay? So, pre-recursion, okay? This is what we call it. It's pre-recursion when this happens, okay? There are 2 types of recursion. Pre-recursion and post-recursion. We have been dealing with pre-recursion. Post-recursion is cake. Post-recursion is easy, stupid stuff, okay? It spits it out as it goes. You will only deal with post-recursion most of the time with print statements, but you can deal with print statements with pre-recursion. So let's take a look at this. What is displayed by Homer 9? Okay, we have our terminating statement is n is less than or equal to 1, and it will print out n. Whenever we have print statements, imagine that you are basically appending a long string. Okay, it's basically an appendage. You are not multiplying, you're not doing anything. The only thing that you can do with strings is append. So let's take a look. Homer n divided by 2. So if I'm doing 9, okay, now n divided by 2, but I have a print statement after this. Okay, do we see a return anywhere? No, which means I still have to run that print statement. Okay, so before I actually run this, okay, I have to store this, comma and 9. Now that I've stored this, I can run it divided by 2, which would be 4, and it stores comma 4. Then it scores comma 2, and then finally it tells me to just print out n, which would be 1 or something 1. So what prints out? I have to work my way back. Okay, I hate this mouse. I have to work my way back. Okay, so what was the 1? And then comma 2 got spit out, comma 4 got spit out, then comma 9 got spit out. So it happens to look like this. Your turn. On one hand, how many times is this going to run? 4 times. Very good. Isis. Oh, Isis. What prints out?
1, 3, 5, 7.
Who agrees with her? Raise your hand.
Oh, wait.
Uh-oh. You guys went too fast. Where's my Vietnamese rock star? There he is. Ashton. What prints out?
Comma 7, comma 5, comma 3, and then 1.
Who agrees with that? Allie girl, what prints out?
I don't know.
Fair enough. Benny!
1, comma 3.
What is it?
1, comma 3, comma 5, 7.
Kennedy, confident Kennedy with a quick shake of the head. Kennedy, what prints out?
1, 3, 5, 7,
Kennedy is right. Okay. And the reason why, what gets stored first? 7 comma. Then what gets stored? 5 comma. Then what gets stored? 3 comma. The comma's coming after. There, in this right here. Anybody see a comma here? I'm sorry, in this one, where is it? Yep. Anybody see a comma added here? No. Done purposely to mess you up. And I didn't even ask Leo. Leo's not even the screen. He's hiding, so I couldn't even ask him. Okay. How many of you got it right on your first try? Be honest. 2. Leo, you got it right? Okay. How many of you just feel, how many of you get it now, but you went too fast? How many of you are pissed because I do this on purpose just to screw you up? Okay. Luckily, I don't care. Now, okay, I do this on purpose because, again, on the last test, how many of you guys missed that easy question with the comma at the end of it on the last test? Okay, slow down. Recursion is actually great because most of the time you're only going to get 3 to 4 road things. You can write it out. And as long as you know whether it's post or pre, okay, then you're going to be okay. Okay. So keep calm and let's kick it up a notch. That's what the picture says. Okay. Multiple recursive calls. Okay. Take a second. Okay. And let's say that I put in the number 6. Take a second. Steak, steak, steak. You are so good. Whoever gets this question right, and can show me their math, does not have to take the exam and gets an A. You got 30 seconds. Oh, now it's party. Excuse me. Oh. 15 seconds. Seven, 6, 5, 2, 1. Ding, ding, ding. Okay. How many of you got 20? Okay. 5 plus 4 plus 3 plus 2 plus 1 plus 6, or 6 plus 2 plus 3 plus 4. Wrong. Okay. This is what it actually is. What you have to do is for everyone, you have to run the method for each one. So for 6, it breaks down to -1 and -2. You have to then do a recursive call for 5 and for 4. Then you have to run the recursive calls for 4, which are 3 and 2, and for 5, which are 4 and 3. Then you have to do for 4, 3 and 2, 3, 2 and 1. Here you have to do it for 3 and 2. Once you hit 1 or 0, you're done. So here for 2, you just have to go one more level. Here, 1 is done, 2, 1 and 0. Here, one more. Here, you've got to break it down. You're fine here, but you've also got to do it for 2, 1 and 0. Okay. Now, whether it's a 1 or a 0, it's all zeros. Remember, if it's n equals 1 or n equals 0, return 0. And if you guys remember that the case was adding, so we were doing plus. So 6 plus 5 plus 4 plus 3, you basically add everything else. And the answer is 38. Now, this is what we call two-step or second level, okay, recursion. You will not get this ever on the AP. This is just more to show you how crazy and how out of hand recursion can get. It took me like 20 minutes just to make this slide, okay? So the good thing is also I have uploaded this PowerPoint already online. It is attached to your homework assignment, okay? Your homework assignment is to do the first 2 recursive statements, okay? The first two, recursion and bunny ears for recursion 1 on coding that. If you get it on the first couple of tries, great. If you don't get it, don't worry about it. Copy and paste it, okay? Copy and paste it into the submission box before midnight, okay? I just want to see if you don't get it. If you get it, great. Some of you already kind of got it. I have a lot of students. It's very rare with students that with recursion that everyone gets it, but it's interesting. I either have kids that get it or they don't. Okay, they either will get every recursion question right and they look at them as little puzzles and they actually really like it, or I get kids that absolutely just do not get this. It drives them insane. They hate it and they get everything wrong. Okay, there's like no middle area. Well, I get about 50% right. It's either they get it or they don't. The key thing is to understand you're looking at it as a for loop. I have no problem doing extra this, like maybe tonight or actually maybe even tomorrow night, maybe doing an extra session if anybody feels like they need a little bit more. I'll email everybody later just saying if you want to hop on, you can. But this is where we're at. Okay? Anybody have any questions? Okay. I felt like this was a good lesson. I felt like this went really well. So again, this your homework is already online. The PowerPoint is online. You will have, now again, for recursion, you will never, ever be required to write recursive programs. You will never be required to write them. Will be required to do them on the multiple choice. So you will have a quiz. Actually, you know what? I won't see you guys until Monday because I don't have you guys tomorrow. Okay, so I'm not going to do can you guys on your honor take a quiz? You will have a quiz. It will be different questions than, because I've got a lot of recursion questions. So, so I will give you guys a quiz on Monday. It sucks I got to give you guys a quiz. I think you're the first class that I meet with on Monday. So right away, I got to give you a quiz. I'm sorry, guys. But other than that, anybody have any questions? We have the time, so please ask away. How many of you kind of understand it already? How many of you really understand it? It's good. How many of you this is going to take a little bit of practice? It's fair? Good. Be honest with yourselves. Okay? Remember, I always say the most difficult things for last. The concepts of recursion, searches, and sorts. We're almost there, guys. Okay? All right, so that being said, homework is online. Are you sure nobody has any questions? Don't be shy, guys. Ask. Okay, right. If anybody is getting confused or anything like that, I'll probably send out an email later today just to see where we're at and if anybody needs extra help, okay? All right, guys, have a great day. I'll see you soon again. PowerPoint is online.
Thank you.
Thank you.